The cubic polynomial f of x is defined by this. Find the remainder when f of x is divided by x minus 3. Given that f2 equals 0, express f of x as the product of a linear factor and a quadratic factor. Determine the number of real roots of the equation fx equals 0, giving a reason for your answer. So that's the question then. First of all, find the remainder then. So part 1. So we use the remainder theorem. So we need f of 3, don't we? Because we're divided by x minus 3. And put 3 in. 2 times 3 cubed. And 3 in there. Plus 3 times the 3 squared. Minus 17 times the 3. Plus the 6 at the end. So what do we get? 27 times 2 is 54. This is 27. Minus 51. Plus 6. So we end up with 54 take 51 is 3. Plus the 27 is 30 and 6. So 36. Part 2. Given that f2 is 0, express f of x as a product of a linear and quadratic factor. So here we've got this cubic. And we're told that x minus 2 is a factor. So it's going to be x minus 2 times so many x squareds plus so many x's plus c. And now we can equate coefficients, can't we? So let's equate the x cubed first of all. 2 on this side. And on this side the cubic term is only from this part here of the expansion, ax cubed. So that tells us that a is equal to 2. Let's do the constants next. So 6 on this side here is equal to, the only constant that comes out here is going to be this one here, minus 2c. So c equals 6 over minus 2 then is minus 3, isn't it? So there's c. Now we'll equate well, the x's, I suppose, or the x squares. Let's do the x squares because there's only 3 of those. So 3 is equal to, now the x squareds come from this term here, b, and then another minus 2a here, x squareds. So that tells us what b is. B is equal to 3 plus 2a. And that tells us a is 2, so 2 2's are 4, and 3 is 7. So b equals 7. That's what we've got then. So f of x then, as a product of a linear, x minus 2, times a, x squareds, 2x squareds, plus b, 7x, plus c is minus 3. So that's part 2. Determine the number of real roots of f of x equals 0 and justify. So part 3. Let's have a look at this quadratic. Here, let's look at this. 2x squared plus 7x minus 0 equals 0 implies, well, we'll consider this. We're going to have a look at when does this equal 0. So let's look at b squared is 49 minus 4 times a is 8, 4 times 2 times minus 3. So it's going to be a plus discriminant, isn't it? 49, 8 3's are 24. Looks like it's not going to be easily done, but we'll come to that now. It looks like it's going to be okay to factorize. So let's see if we can factorize it then. Let's have a look at it. 2x, x. Let's try 3 and 1. But is that going to work? 3. That would need to be a... Yes, it's not going to work there. So we need to solve the quadratic then. Using the formula. X is equal to minus b plus or minus the square root of b squared, 49, minus 4 times the 2 times the minus 3 over 2a, which equals minus 7 plus or minus. Now we looked at this before, but 4 times minus 4a times c, so I need a 2 there. I've managed to write 8, a 2, 4 times a times c, there we are, and that became a plus. 8 3s are 24, 24 and 49 is 69, 73 over 4. So fx is equal to x minus 2, x minus the next root. The first one will be minus 7 plus root 73 all over 4. And then the next one will be x minus the minus 7 minus root 73 all over 4. So we can tidy that up. Let's just tidy it up then. X minus 2. X. We'll run the, we could run the minus through. Plus 7 minus root 73 over 4. Just run the minus through there. And this would be x plus 7. This was a minus and a plus, so that was a minus. This is a minus and a minus. Plus root 73 over 4. Okay, so there's the roots. So what did the question say? Determine the number of real roots. Oh, so we didn't really need to work that out because we could have just looked at this discriminant. So we didn't really need to do that work there because it didn't ask for the real roots since the discriminant in the quadratic is positive. This is all we really needed to say.